In this lesson, you're going to explore the big idea of properties, and it's important that you walk away from this lesson understanding that a monomial can be multiplied by a polynomial using the distributive property, and that factoring a polynomial reverses the multiplication process. So in Algebra 1, you talked about the distributive property. Now in Algebra 2, we're going to talk about undoing that multiplication using a process called factoring, which relies heavily on the concept of division. The first step when factoring a monomial from a polynomial is finding the greatest common factor of the terms in the polynomial. So this lesson focuses on the idea of factoring by GCF. A common factor is a number that is a factor of two or more terms. So for example, if two terms are both divisible by 2, then 2 would be a common factor of those terms. The greatest common factor is the greatest such number that is a common factor of two or more terms. So it may be possible that, two terms have common factors of 2 and 4. They'd both be considered common factors, but 4 would be the greatest common factor. Looking at a couple of examples, we want to find the GCF of each set of terms. The first set of terms that we want to find the GCF of is 18 and 27. This process also typically begins by finding the factors of the two terms that you're looking at. Hopefully your multiplication skills are going to be strong enough so that you can begin to immediately recognize what the common factors are. But let's look at the process a little bit more longhand this time. Let's list the factors of 18. We know that 18 is 1 times 18, 2 times 9, and 3 times 6. The numbers 4 and 5 don't go into 18. We look at the number 27. That's 1 times 27. 2 doesn't go in, but 3 does. 4, 5, 6, 7, and 8 do not go into 27. What we want to do is compare the list of factors and look for common factors. Well, we see 1 in both sides, we see 3 in both sides, and we see 9 in both sides. Which one of those is the largest common factor? The answer would be the 9. So 9 is the greatest common factor of 18 and 27. You've looked at the concept of greatest common factor before in your math classes. In Algebra 2, it's important that you can expand upon this to include algebraic expressions. So that's going to be expressions involving variables. You want to break this up into two different things. First, you want to find the GCF of 6 and 15. Well, 6 is 1 times 6 and 2 times 3. 15 is 1 times 15 and 3 times 5. So the largest common factor that we see here would be 3. Then we want to find the GCF of x squared and x. It's really important to note that when you're finding the GCF of variable terms, they have to be the same letter. They have to be that same variable. And what you want to look for is the lowest power. Now we're able to find a GCF of an x squared and an x term because they both contain the letter x. Here the lowest power would be x. So the GCF of 6x squared and 15x is 3x. In the essential understandings, we talked about the distributive property and how you use that in Algebra 1 to multiply a monomial times a polynomial. Let's look at an example. If we want to multiply 3 times x plus 2, we would multiply 3 times x to get 3x and 3 times 2 to get 6. The process of factoring asks us to undo that multiplication. And when we factor, the first thing we always do is look for a greatest common factor. So what's the greatest common factor for the terms 3x and 6? The answer is 3. When we factor by GCF, the GCF comes to the front of a set of parentheses, and then we factor it out of each term. Factoring undoes multiplication. So if you think about inverse operations, which we've been looking at a bit in the Intro to Functions unit, the inverse operation for multiplication is division. So factoring relies heavily on division. If we remove 3 from the 3x using division, we would be left with x. If we remove 3 from the term 6 using division, we would be left with 2. Notice that when we factor by greatest common factor 3x plus 6, we're left with 3 times the quantity x plus 2. Let's look at a couple more examples. In these examples, we want to factor completely. The process of factoring is always going to begin by looking for a GCF. So let's start by finding the GCF for the terms 14x and 21. They don't both contain the letter x, so our GCF is going to be strictly numeric here, and the greatest common factor of 14 and 21 would be 7. So 7 comes to the front of a set of parentheses, and now we essentially use division to factor 7 out of each term. It's going to leave us with a 2x minus 3. The directions say to factor completely. So what it's important to do here is to look at what's inside the parentheses and ask yourself, is there still a greatest common factor there? The only common factor that the numbers 2 and 3 share is 1, so there's no more common factor that we can take out. They also don't both have the same letter. So that leads us to believe that this is the completely factored form. Moving on to the next example, we want to factor 6x cubed plus 18x squared. Again, what is the GCF? Start with the numeric piece. What's the GCF for 6 and 18? Answer is 6. We have an x cubed in one term and a y squared in the other. Since they're not the same letter, the variable cannot be included as part of the common factor. We'll put our GCF of 6 out in front of parentheses and then factor it out of each term using division. Doing that on the first term, we're left with x cubed, and doing that on the second term, we're left with 3y squared. Again, look at what's in parentheses. Is there still a common factor there? Is there more that you can take out? If there is, you have to keep going in order to ensure that you've factored completely. Let's look at one last example. I recommend that you pause the video here and try this one on your own. Okay, hopefully when you try this on your own, you determine that the GCF for 10x squared y and 15xy squared was 5xy. That GCF comes to the front of parentheses, and when we factor it out of each term, we're left with 2x minus 3y. Factoring is a very important concept that allows us to change the structure of expressions so that we can look at things differently. It's going to become a very important part of this course and also your work in other upper-level mathematics courses. GCF is just the very first step. I recommend that if you have questions that you highlight them in your notes now so that you can ask about them when we return to class.